eat 12 dodecagons.
Well, actually, your statement is not an appropriate usage of the hyperbole, since you did not provide the size of the dodecagons. Therefore, it can be reasonably inferred that they were of minuscule size.
Well, actually, they keep me in shape. In shape.
Well, anyways, if you're so hungry, why don't you try this delicious soup I made? It's a special recipe.
Oh no, not one of your culinary school assignments. Last time I tried your food, everything turned round. Life seems so pointless. Anyways, do you cook it in 180 degrees Fahrenheit?
What? No! It'd be undercooked. Besides, I'm better than that. Just try some.
Wow, it seems as you pour the soup into the bowl, the height of the soup changes. Does that mean the height of the soup is changing at a specific rate?
Why, yes, I'm glad you asked. With the power of calculus, we can solve for different rates of change of multiple measurements of the soup in the bowl. To the math board! These glasses aren't even prescribed to me.
Meera is pouring soup into a perfectly hemispherical bowl that has a radius of 4 inches, and the soup's volume in the bowl is increasing at a rate of 3 inches cubed per second. What is the rate of change of the height of the soup from the bottom of the bowl when the height of the soup from the bottom of the bowl is 2 inches? Provided above is the formula for the volume of a spherical cap. The rate of change of the volume of the soup is given as 3 inches cubed per second. We begin by plugging in the value for the radius of the bowl, which is 4 inches. Then we solve for dH dt, which is the rate of change of the height of the soup in the bowl. We plug in 2 inches for the height of the soup and isolate dH dt. This leaves us with dH dt being equal to 1/4 pi inch per second.
Wow, I get it now. Wait, does that mean the radius also changes at a specific rate?
Oh my, you seem to be correct. This time, you give it a go.
When the height of the soup that Meera pours into the bowl is 2 inches from the bottom of the bowl, at what rate does the radius of the soup increase? In order to find the rate of change of the radius when the height is 2 inches, we have to find the actual length of the radius when the height is 2 inches. So to do this, we need to use Pythagorean theorem. We know one length is r. The other length would just be 4 minus h, and h equals 2 inches at that time. So if we plug in 2 into our equation, we can finally solve for the radius, which is 2√3. Afterwards, we take the derivative of the Pythagorean theorem and our original equation, and then we can isolate our variables to find dr dt. So now that we took the derivative of the equation, we can simplify it by dividing all sides by 2, and then we get our new equation. We plug in the radius equaling to 2√3, and also, from our previous answer, the derivative of the height equaling 1/4 pi. Finally, isolate for the variable dr dt to get 1/4 pi root 3 inches per second as the rate of change of the radius when the height is equal to 2 inches.
You know, all this math is making me an awful lot of hungry. I might as well try some of this delicious soup. Yeah, this isn't even as bad as the last.
Get your money, man. Life goes on.
I'm hopeful, yes I am hopeful for today. Take this music and use it. Let it take you away and be hopeful, hopeful, and he'll make a way. I know it ain't easy, but that's okay.